Department of Defense Manufacturing Technology program develops and supports the adoption of advanced manufacturing technologies. Some of the goals include lowering the cost of production and the cost of repair and maintenance, increasing the capability and the quality of the products that the military purchases, and also increasing the production throughput of those items.
The Manufacturing Technology program identifies and solves problems across the defense industrial base by working with the Joint Defense Manufacturing Technology Panel and its technology-based subpanels to identify joint technology pursuit areas.
We all work together to ensure that we're meeting requirements for the military services themselves, all the way to strategic partnering with industry and academia through our manufacturing innovation institutes, which work on scale-up, commercially relevant advanced manufacturing technologies.
Our program is focused on the efficiency and affordability of technologies, and we enhance those things through enhancing the manufacturing processes for that. And the end goal is to support weapon systems to enhance warfighter capabilities.
We are at the Watervliet Arsenal. Our engineering facility is part of AFC DevCom Armament Center, and our mission is to provide research, design, and development of large caliber cannon.
The project that we have is called Electrochemical Machining for Armament Manufacturing. For future cannon designs and looking at alternative materials, we needed to have a different broaching process or rifling process to be able to rifle large caliber cannons. Broaching is a conventional manufacturing process that uses a successive set of broaches that shear off very small amounts of material. Broach sets are very expensive. So with electrochemical machining, it's a non-contact process, so your tooling is much, much cheaper. We can get faster processing rates and get an improved quality with this process.
This project started off as an S&T development effort. As the technology matured, it was transitioned to a Mantech program. With the support of the Mantech office, this technology will reach a manufacturing readiness level to allow it to be transitioned into production manufacturing processes.
This was specifically under the Mantech program for the M284, which is on the Paladin system. But the technology is also very pervasive. So we could use this on 105 millimeter. We can use this on 7.76, which is the M77 towed artillery system. Long-range artillery, we can use it for that as well.
The investment of the Army Mantech office in electrochemical machining allows us to advance the technology that currently exists for rifling large caliber cannon. It will also offer us flexibility and agility moving forward into our newer designs so that we may provide superior weapon systems.
I consider it a success because we started out as a very small effort, and then we built this full-scale facility and then demonstrated that we can rifle large caliber cannons with it. We've been doing this for the Mantech program since fiscal year 19, so we just ended our 4-year program, and we're now going into our transition phase where we're taking that from a MRL-7 technology and pushing that out to the shop floor.
It's very vital to the mission because whatever the U.S. warfighter has to use within combat situations, it has to be manufactured. And if we can't manufacture it, if we can't manufacture enough of it, then it reduces our ability to have overmatch against the adversary.
The mission of the Navy Mantech program is to develop new and improved manufacturing processes with the goal of reducing the acquisition and lifecycle costs of key Navy platforms.
Navy Mantech works in conjunction with the Centers of Excellence and the shipyards to generate ideas that would have the greatest impact, cost savings, or capability acceleration for the Navy and for the warfighter.
Today you are at Ingalls Shipbuilding. We build surface combatants for the U.S. Navy, as well as the Coast Guard, and any commercial opportunities that we have as well. The Shape Plate Robot project is taking a process that it took over 40 years for a craftsman to create his art in order to shape plates.
The existing process involves using a flame-based torch to heat and then cool the metal.
We've taken that science, put it into a robot that used programming to take his art and repeat that process to shape that plate.
What the robot is doing, it's taking flat pieces of steel and forming them into specific shapes that go into various components that will then be installed on the ship. And the goal is to shorten the process of fabricating these plates from somewhere on the order of 50 to 60 hours to hopefully around 4 hours. And that's a tremendous cost and time savings for the Navy.
We've had over 44 projects that are implemented or in the process of implementing, with the total savings over $27 million per hull. And we've done all kinds of projects with them, from new improved welding processes to digital thread technologies and other technologies that really reduce the cost of ship fabrication and accelerate the delivery of those assets.
This project supports the Navy and the warfighter, generating cost savings for the Navy and allowing those research dollars to be used for new capabilities and bringing those to the warfighter more quickly.
They provide expertise in cutting-edge technology that as shipbuilders we would not usually be accustomed to or even familiar with. So that partnership really provides us benefit to grow, learn, and continue getting better and reducing costs for our customers.
The Air Force ManTech program is really focused on driving affordability into our weapons systems, manufacturability into our weapons systems.
We're at Compass Technology Group. They're running our project called the Advanced Radome Diagnostic System, ARDS for short.
What we have found is with the manual tap tests that the depot typically uses, we don't discover problems with the radomes not being properly repaired or missing areas that need to be repaired until we get out to test in the field after the depot. And then we have to do rework, and it usually leads to 80 hours plus of rework that needs to be done.
Radomes are very important to a plane's ability to locate targets, to locate the ground terrain, to make sure that it sees weather ahead of it. So we need to make sure that those radomes are at their peak performing capability, and this system helps ensure that we're doing that. This system will allow us to test the performance midstream or even at the beginning to give us a baseline to know how to best make those repairs.
We take millimeter wave radio frequency measurements, and by using those measurements we can look at the transmission and reflectivity of different objects and materials. So we use those to look at the paint thickness or the layer thickness of the radome and evaluate its health and performance.
This is about the third year of the project. It started off as a handheld unit that we were using to measure radome transmissivity. We transitioned that to a robot, and now what we're doing is using that data to go do further testing and proof of concept on radomes. The ManTech program is important to innovation because they pull technologies that are in the development stages. They get them ready for prime time to allow us to then push that into production. So they help us bridge that gap of technology readiness to get us to a spot where we're ready to transition.
Really, for us to ensure that our warfighters have the capability they need, we need to invest the government dollars in building that industrial base. We need to ensure that the suppliers exist, that we have domestic suppliers, that we have access to suppliers so that we can provide the capabilities that the warfighters need.
I'm the Research and Development Director. And ManTech is the largest of the three components of our R&D program. It involves basically sustainment of key supply chains. It's all about the defense industrial base and really keeping it ready for DLA sustainment.
We're at Redstone Test Center, located on Redstone Arsenal, Alabama, and we do testing for Army hardware.
So this is a project that we've been working with the Army, and it's part of our additive manufacturing portfolio. For DLA, it's really about getting additive manufactured parts into the aviation supply chain.
The name of the project that we're highlighting is the Additive Manufacturing U-860 Fuel Elbow project. And because of supply shortages that had to do with manufacturing quality escapes, the program office and DLA and the Army's DEVCOM Aviation Missile Center of ManTech got together to design, build, and test an additively manufactured fuel elbow.
The goal of the project was to do a 10-hour test flight on a U-860 helicopter here at our airfield.
Additive manufacturing is the ability to take a CAD model, a computer-aided design model, and put it into layers into a machine. So the machine deposits layers of materials.
This is actually a fuel elbow. What this does is this end connects to the fuel hose, and then this end connects to the engine. So this actually supplies fuel to the turbine engines.
So the fuel elbow had a manufacturing quality issue. It had a thin wall on one side of the fuel elbow that was causing small fuel leaks.
The importance of this project is demonstrating that we can print these parts and qualify these parts to a certain airworthiness qualification and fly these parts in a limited test flight, which is really just exercising that whole process so that in the future, as additive technology improves and advances, we can move forward and continue to add parts to the aircraft as needed to help sustain it.
We definitely consider the project a success. The fact that it was a joint project was very beneficial. The fact that we were able to pool resources, different organizations, and we had a stated goal and we met it at the end.
It is important that DLA establishes these partnerships, not only with the military, but also with academia and industry, because when you bring different perspectives to a problem, you find better solutions to it.
Success can be defined in a number of ways. In a lot of ways, it's making a better part, getting it qualified so it can be part of the new part that you'd order for that weapon systems. Other times, it's improving a business process for DLA, like moving us from a 2D technical data world to a 3D connected digital enterprise. So success can take different approaches, but for us, it's really all about support to the warfighter.
Mantech is really working on securing the supply chains in the U.S., increasing the resilience of the supply chains so that we can respond to not only to daily products that you and I use all the time and upgrades to those products, but also respond to the warfighter needs and support national security, but also through economic security and creating better jobs for the U.S.
The DoD Mantech program is very important to the defense industrial base and the warfighter because we are investing in next-generation technologies, ensuring the manufacturing processes are advanced and improving so that our warfighter has access to asymmetric advantage on the battlefield.